So the next parameter to consider is sample loading. So the injection volume and the concentration. Now with the polymer concentration, you don't want to overload the column. That will lead to a loss of resolution. But at the same time, you need enough sensitivity to ensure that you have accurate measurements of the polymer. With injection volume, too large an injection volume can lead to mass overload. But also you're going to, by increasing the volume, you're going to increase the peak volumes, and that's going to contribute to a loss in resolution. So there's a play between concentration, making sure you've got the viscosity, making sure you've got the sample loading, and the injection loop size itself. So here's a couple of examples of the impact it can have. So this is with high concentration, and you can see it across this range of standards. At the high end, you can start to see that you get degradation of that peak shape, and that's because of the high concentration of polymer. So in case the legend is too small, the top one is 25 microliters, goes down to 20, 15, 10, and 5 at the bottom. And you can see on the bottom one, you've got that resolution of that high polymer standard, whereas in the top one, you have poor resolution. Here we have, similarly, starting at the top, 25, going down to the bottom of 5. If you decrease that concentration, then you can actually start to use larger injection volumes because the mass overload is reduced. So this is exemplified most in that middle section, whereas before you had, again, a poor peak when you had a high concentration. At lower concentration, it allows you to inject a bit more, and that 50 microliters one is now, again, a correct peak shape. When you want to compare, in this case, 10 and 25 microliters, to the naked eye, it may not look like there's a lot of difference. If you normalize and overlay, you see that there is subtle differences there in the distribution, and you are losing a little bit of resolution. That's going to be seen in the blue trace compared to the black trace on the bottom half of the screen. For advanced detectors, because with the APC, you have this higher resolution, therefore you have narrow peaks, you have tall peaks. It reduces the limits of detection, of quantitation for advanced detectors. So this is data which was presented by Malvern Analytical, and they've got a 20-fold reduction in the LOQ when comparing APC to GPC for light scattering, and 10-fold for viscometry. So this allows you to look at either much lower column loading to avoid any of those problems we saw in the previous slides, or also, of course, more sensitive to smaller quantities of material present. So, for example, looking at additives. It's really important when you're starting to think about detector considerations to make sure that you have ones that are appropriate for the APC. So here's an example of looking at a traditional HPLC RI detector compared to the Acuity RI detector. And you can see, because of the large cell volume in an HPLC detector, you lose a lot of the resolution. So when you go through all your different detector options that you want to make sure that you get the correct information, you have to bear in mind that you need ones that are suitable for this level of high resolution chromatography to avoid a reduction in your end resolution. This is, again, an example provided kindly by Malvern Analytical, where it shows that you can now use advanced detectors on this system without losing resolution, as can be seen on the right-hand side image, which shows the APC trace using the advanced detectors, and you can see you've got very high resolution there. The middle one is not using APC, so you can see you've lost resolution there. And the left-hand trace shows the time increase, so you've gone from traditional 30-40 minutes down to sub 10, so 5-6 minutes.